All right, so we're gonna do another video here, mutual exclusivity and the addition rule. Ooh, little kitty. Ooh, there's little kitty. She wanted to make an appearance. She was jealous of all my camera time. Anyway, so we talked about the multiplication rule. Now we want to talk about the addition rule. Remember, the multiplication rule had to do with intersections. We're talking about two events A and B both happening. Mutual exclusivity and the addition rule have to do with unions or one or the other event happening. Okay. So my fancy pointer. Mutual exclusivity means that the two events cannot happen together. They are mutually exclusive. So rolling a fair die and getting both a 2 and a 3, right? Those two events, the event of rolling a 2 and the event of rolling a 3, they are mutually exclusive. They cannot happen at the same time. If one happens, the other cannot happen. That's mutual exclusivity. And a good way to visualize this is in something we call a Venn diagram. Okay, so in a Venn diagram, we're looking at, remember we talked about sample spaces being the total amount of possibilities or the total number of possibilities for an event. So if we think of this rectangle, the area of this rectangle is the total probability equaling 1. And the probability of event A is the amount of area in this circle compared to the 1 of the total sample space, and the probability of event B being the area of this circle. Okay? So in this case, they don't overlap. So if A happens, if anything in this circle occurs, then this doesn't occur, right? There's only going to be one thing that happens. Either something out here happens, which is neither A or B, something in here happens, so event A happened, but event B didn't happen, or here event B happens and event A doesn't happen. So A and B have no outcomes in common. So when we look for the union of those two events, all we have to do is add the individual probabilities. So the probability that either A happens or B happens, we just add up the area or the probability of A to the area or the probability of B, and we get our probability of the union or the A or B question. That's where the addition rule comes into play. We're adding the two probabilities together. Now, if they're not mutually exclusive, ME for mutual exclusivity. If they're not mutually exclusive, well, that means that there's possibility that both things can happen at the same time. So think about the events of picking a card from a deck of cards. Let's say one event is picking a queen, one event is picking a diamond. Well, you could get a queen of diamonds, right? So that's an example of two events that are not mutually exclusive. They can happen at the same time. Now, if that's the case, again, we'll look at a Venn diagram, but in this case, we're going to have some overlap, right? And this space where they overlap, that's the probability where they both happen. Again, remember, this is the symbol for intersection as opposed to the symbol for union, right? So where they overlap, that's the case where both A and B are happening. All right? So now if we go to the formula for the union, if I want to know what's the probability of either A or B happening, just like we did here, I'm going to take the area or the probability of event A. I'm going to add it to the probability or area of event B. But notice when I do that, I'm counting this overlapping part twice, right? When I count the probability of A, I'm counting that shaded area. And when I add the probability of B, I'm also counting that shaded area. So I'm counting this area twice. Well, all I really want is the sum total of all the enclosed area here. So that's why I'm subtracting that value once, because I added this amount twice, so I'm subtracting it once. So if the two events do have overlapping outcomes in common. We're adding the probability of A plus the probability of B, and then we're taking the overlap away once because we counted it twice. So that's the formula for the union of two events when the events are not mutually exclusive. Now, just like we did, if you remember, for independent events, we can get this back to this equation by realizing that if these two events are mutually exclusive, then this is just going to be zero, right? They don't overlap in this case. So the probability of those both happening in this Venn diagram is zero. So really this equation and this equation represent the same thing of the union of A and B. If they're mutually exclusive, this just turns out to be zero, and we're back to where we were right here. All right, so that's mutual exclusivity and the addition rule. Let's go through an example here. Let's say we're given some information about two events, A and B, and we want to find out the probability of their union. So let's say we're given the probability of event A is 0.2. The probability of event B is given to us as 0.5. And we're given this conditional probability that event A happens given that event B happens is 0.3. And the question is, find the probability of their union. Now, looking at this and going back to independence, maybe you can see this. I'd like you to see this, but you can tell just from this given information that these two events are not independent. Now, we're dealing with mutual exclusivity here, but just going back to our previous lesson, you should be able to see that A and B, if you were asked, are these events independent? You should be able to look at this information and say no, because the conditional probability, the probability that A happens given B, if they were independent, then that condition wouldn't matter, and this value would be the same as this value, right? If they're independent, then the condition that B happens has no effect on A, so it should be the same as the probability in A. So you can see if that's not true, you immediately know that they're not independent. Okay, so that's just a bit of an aside, but hopefully you can start to begin to notice these things. All right, so we're given this information, we're asked this question. So we don't know if these events are mutually exclusive. We're not told. If we were told that they were mutually exclusive, we could just add these numbers up, right? If we're told. If they're mutually exclusive, we could just add them up, but we're not told that, right? We are not told that, so we have to assume that we're using this equation. So we need the probability of A, we need the probability of B, we have both of those, but we also need the intersection to come up with this answer. Well, we're not given the intersection of A and B. We're given the conditional of A given B. So we need to find this. Well, we have to come back to our independence formula. Or I'm sorry, this is the union, right? This is the union of A and B. We're using this formula. We need this. So we need to find the intersection of A and B, right? We need this part of this formula. This is what we're using. We're using it here, but we got to come up with this part here. So we go back to our previous lesson, and we know the probability of A and B. We could say probability of A times probability of B given A, but we're not given. This is what we were talking about last time in the way that we can look at that formula in two different ways. So this is a perfect example of that. I want the probability of A and B, but I'm not given the formula in this order, so I have to use this order, which we talked about in our last video. If I take the probability of B and A, now I have all the information I need. Probability of the first event times the probability of A given B. I was given that value. Now I have everything I need. Probability of B, probability of A given B. So that gives me my answer to this question, which is the same as this, which I'm using in this formula. Well, sorry, this is the same as this, right? B and A and B. So I use that here, probability of A plus the probability of B minus their intersection, and I come up with my answer of 0.55. So also this tells us that the events are not mutually exclusive, because if they were mutually exclusive, their union would be the sum of these two values. So these are the things you want to notice. Since this value is not 0.7, we know A and B are not mutually exclusive. All right, so good times. And we'll move on to the next subject very soon.